Hi, my name is Mike Hagenow. I'm a postdoc in CSAIL and part of the interactive robotics group at MIT. My goal in robotics is to develop these really capable, highly intelligent robot teammates. The kind of robots that you can rely on to help you with tasks, to do the mundane parts of the task that people don't want to do, but ultimately are relying on sort of the human skill that's necessary to complete many complex tasks that really aren't possible through automation today. So my work here at MIT focuses in two areas, teaching and teaming. So on the teaching side, I'm interested in how people can get data to robots for complex tasks, for example, in manufacturing. And on the teaming side, I'm interested in how robots can work together with people to get complex work done. Here, I'm interested in trying to make sure that the robot's taking on the physical burden of doing the task. So in manufacturing, many of the tasks that we look at are very taxing, ergonomically challenging, and so having robots assist is really beneficial. But robots don't always know what they need to do. And so I also look at uncertainty-aware methods where robots can reason about their confidence in doing the task and then effectively elicit information from people to make sure that the task is done right. So one of the projects I've been working on here is focused around robots using generative AI and using the generative AI so that robots can reason about what they know about a task, where they're uncertain, and the types of ways a person might give help in these scenarios. So the idea here is that by using a generative AI policy, the robot can sort of look at the different ways it might be able to do a task. It can sort of forecast the different trajectories it might take, the actions it might do, and then it can look at when there's uncertainty. So for example, taking multiple different paths, different level of forces when you're maybe doing some sort of manufacturing task. Maybe it's even just that it has simply no idea how to proceed on the task. There's an uncountable number of ways it thinks it might do it. How can we sort of combine this with the different ways that a person might give input? So for example, answering simple yes or no questions. Should I go this way versus this way? Asking the person for partial input. Maybe the person just controls an axis of the robot's motion, like the force that it's applying while the robot takes care of the rest of the motion. Or maybe also just completely handing over control when the robot's really uncertain. The person's able to show the robot how to do that part of the task and it can learn from it for future instances. So in this way, we can sort of bring together the uncertainty and the different ways a person might provide feedback to a robot. So it's been an incredibly amazing experience being part of CSAIL. Every morning I start my day in this data center, grabbing coffee, and then it's remarkable just to have the casual conversations that come with being around all of the different people working in interesting areas in AI, technology, machine learning, and robotics as well. It's been really, really fulfilling attending the different seminars available in CSAIL, the social events, opportunities to really meet and network with other researchers that are really interested in ways that we can make AI make a positive difference for people's lives. So looking forward, I'm really excited to continue to develop new human-robot interaction techniques, focusing on sort of these core aspects that I've identified for manufacturing and other critical domains where I think robots can continue to build as helpful assistants. So looking at ways that we can more effectively teach robots and collect data in more efficient ways. And then really, and critically important, looking at the ways that humans and robots can collaborate and team together. The methods we can develop for this, the systems, and really ultimately trying to get some of these setups out in practice doing real work.